Hey guys, good morning all. Just give me a chat if you guys can hear me and see the sublime text. Quickly give me a chat if all of you guys can hear and see the sublime text. You guys can? Cool. All right, let's quickly start with today's session. We are a bit delayed throughout today's session, but anyways, let's quickly start with today's session and then we'll revise what you have to do. All right, in the last class, we have completed our dynamic programming and we start with the backtracking. We have not covered many backtracking questions. That's what we'll be focused on. Most likely, we'll be finishing the backtracking today. If not, by tomorrow, we'll be definitely finishing the backtracking. Quick check. On the dynamic programming, we first talked about what exactly is DP, what's the difference between DP versus recursion, what's the difference between backtracking versus recursion versus DP, and then we have finally moved on to the questions which were done based on terms of dynamic programming. We talked about introduction to DP, a real life example to understand how DP work versus recursion works. The most important part, 4 steps to solve any DP question in the world, no matter which dimension of the DP. And then we did question based upon maximum steps, which is climbing stairs, removing chocolates, variation of sum of numbers, etc. etc. Okay. And one 2D DP problem, which is gold mine. We also did the decode ways, and I think there is one more question that we have done on DP. Okay. All right. Last class we started with question number 9, which is decode ways. What is the question? Let's talk about it. The problem statement says you have given an intercepted message encoded as a string of numbers. You need to decode it via the mapping. So you are given a number in a string format. You need to tell me in how many ways it can be decoded. For example, 12 can be decoded in 2 ways. If you take it as 1 and 2, it can be AB. If you take it 12 as a number, it can be decoded as L. So 2 ways. 2 to 6, there are 3 ways. 2, 26, 2, 2, 6, 22, 6. Okay. 0, 6, it is not valued there, so output will be 0. So this is the function that you have to complete. You have to return the number of decodings possible. Okay. How much more is remaining in DSA? 20%. Or maybe even less than 20%. Once we complete backtracking, we'll move to trees and graphs. That's the last pending topics we have. Okay. I usually take one doubt clearing session in case there is any other topic, for example, articulation points or Fenwick trees and any of those high level topics, or in general, if you have questions for any topic, I usually take like one class for that. Okay. If all of you have doubts, if it's an individual doubt, it's most usually useful to get by mentor instead of instructor. Okay. LRU cache is not a separate topic in data structure algorithm. Is there a question you want to do on LRU cache that we can do, but it's not a separate topic per se. Greedy, we can cover a question as such. By September, it will be completed. By August, it will be completed. Next month, it will be completed. Okay. All right. Now coming to this, for the understanding of this, we all talked about the understanding. Coming to the solution part, number 1, when we say leading zeros will not contribute to answer. So DP of 0 will be 0. When we say alphabets, A to Z is going to be 1 to 26. Now it can be categorized into 2 categories. If it is 1 digit between 1 to 9, it is corresponding to only 1 entry point. So DP of 5 will become DP of 5 minus 1. If it is 2 digits, which is between 10 to 26, there is going to be 2 entry points. So DP of 5 will contribute to DP of 5 minus 1 plus DP of 5 minus 2. Okay. Then we wrote the DP based solution. First, we check if there is any leading zero. If there is any leading zero, there is no point to calculate the answer. We pass the first digit and the first 2 digits. Then we check the condition we talked about and we return our answer. Time comes to big of n, space comes to big of n. If you try to solve it by recursion, this will lead you to TLE. If you solve it by DP, it will pass all the test cases. Okay. Then we move to question number 10, which is lead code 322, which is coin change. I think this was the extra question that we covered. It's a good problem statement. What the problem statement says is you're given a denomination of coins and assume that this is infinite amount of coins and you're given an amount. You need to tell me the fewest number of coins that you need to make up that amount. Okay. So return the fewest number of coins, the same as return the minimum number of coins. So this identifies a DP based problem. Now, there's a brute force way of solving this, and then we'll move to the optimized way. What's the brute force way? I can go branches raised to the power depth. So branches is going to be array size, depth is going to be amount. What I can do is, first base condition, if amount becomes negative, I'll return -1. If amount becomes equal to 0, I'll return 0. There's a difference between the two. -1 means it cannot be achieved. Amount becomes 0, you don't need any coins. That will become 0. Okay. Now what you're going to do in recursion is, I will keep on reducing the amount minus coins I, and then I will recur if the value is greater than 0. If my answer is not negative, then it will become value plus 1. Otherwise, I'll take the minimum of answer comma value plus 1. Okay. Then we move to the optimized solution, which is DP. What are we calculating in the DP is same thing that we have done in the recursion. These are the base conditions. Now, instead of doing branches raised to the power depth, I can do branches into depth here. So I'm doing 2 nested loops here. So in that 2 nested loops, what I'm trying to calculate for my DP is, if the number of coins is greater, find the minimum that I got from using the minimum coins plus the current value of coins. Okay. And if I reached as a dp.length means I'm able to consume all the coins, then you return -1 because you're not able to achieve that. Otherwise, return the number of coins required there. Time complexity coins.length into amount, these two nested loops, space complete big of amount. This is the most optimized solution for this. Then in terms of overall DP solution, we talked about the template. There are 4 steps. Most likely you will be solving a problem by tabulation, which is bottom-up approach. Otherwise, in some cases, you can go for memorization. Finding the state relationship is the most important. The first one, two, and the fourth step is easier one. Intuitive is think of a recursive way, then try to convert into DP. Optimized solution is you see the template, find the state relation, write the DP code. Okay. I think we set up the target to be 8 to 9. We were able to reach to 6 to 8, which is fine. Not very good, but which is fine. In order to reach to 8 to 9 or even more to 10, there's more number of problems that you need to solve. And more than the number of problems, more number of patterns that you need to solve for. Okay. So you probably would have received already the assignment for DP. If not, I'll ask the course coordinator to provide it to you. That will give you more insights of the patterns or the quality of questions to target for. Okay. All right. Then we start with our current topic, which we have started, which is backtracking. I did not start directly with the theory of backtracking because I wanted to first make you understand how the questions related to backtracking look like. Once we're able to identify the question, then we can go into the theory of it. Another reason for that is the theory of backtracking is pretty much simple. It's not as detailed as DP. There's a template also, but there's only 2 steps in the template. There's no 4 steps. Okay. So it's important to understand the pattern of the question rather than understanding just the theory part of it. Okay. So first question that we tried to solve was variation of sum of numbers 135 asked in Adobe. Now this question is what we have solved in DP also. Just something has changed. What has changed? We were given 3 numbers. We need to form a number n using some of these 3 numbers. In a DP based question, I was asked number of ways. In this question, I'm asked check if it is possible. So if you look at this, if I have to make 6 using 1, 3, and 5, there are 8 ways. Output is true. If I have to make 7, I can make it. Output is true. If I have to make -1 using 1, 3, 5, I cannot. So output is false. Now, one way of solving this question is you can convert into a DP problem and then you can check if there is absolutely no way, then you return true, otherwise return false. Okay. So permutations can be taken big of array.length raised to the power value. That is the total number of permutations that you can think of. Divisibility will not be an answer. If somebody is thinking that we can just check the number is divisible by all the numbers in the subset, that is not a valid case. For example, 7, it's not divisible by 2, 3, or 5, but you can make 7 by combination of 2, 3, and 5. Okay. So merely checking on divisibility is not the right way. Anyways, the only difference between the DP problem and this problem is this statement asking check if it's possible. Okay. So whenever you see, and we'll come back to a theory of backtracking, whenever you see such kind of statement where the problem is asking you whether you can do it or not do it, check if it is possible or not. In those cases, question is triggering you to check all the possible permutations, all the possible combinations, and then give a decision whether you can or you cannot. Okay. If it was simply asking number of ways, then we just need to have a formula to calculate that or state relation to calculate that. But when the language of the problem is that you have to find every possibility and then come with a conclusion whether it can be true or false, that are backtracking questions. Okay. Second question we moved was a subset sum problem. But before subset problem, I revised you the 2 questions for 2 sum. So for 2 sum is a straightforward question. Array is given, a target is given. There's going to be a pair with sum equal to target. You need to check out what is that pair with equal to target. Either you have to return true or you have to print that here, so on and so forth. So we know there are 3 solutions for it. One is the brute force solution, 2 nested loop, one is sorting and 2 pointers, one is hashing. Now, extension of this 2 sum problem is this subset sum problem. Now, what is that extension is? You are given an array. The only requirement is instead of a pair, you have to use any combination. Now, this any combination word is important. You can use any combination in the array to make sum equal to target. Okay. So if you're able to find any combination, return true. If you're not able to find any combination, then return false. For example, if you look at this problem, 1, 2, 3, 4, 5, 6, target equal to 6, there can be many combinations which can actually accumulate to 6. Okay. So the output will become true. The biggest blocker of solving this problem is even if you know that I have to find a KSH combination, at least you can write a brute force code of n raised to the power k that will work. But in this case, you don't know. Brute force of n raised to the power k will not work either. Okay. Because the size of combination is varying itself. So this is the biggest kind of problem that we solve by backtracking. Wherever you find the condition, check if it is possible. Wherever the problem is triggering you to identify whether it can be done or not, basically check all the possibilities. Those are backtracking questions. Okay. All right, guys. That being said, that was a revision till last class. If everybody clear, give me clear in the chat so we can start with today's session. All good? Cool. Now we are going to start with backtracking in detail. All right. What exactly is backtracking? We discussed during the time of backtracking versus DP versus recursion, or backtracking versus DP versus greedy. Backtracking is optimization over recursion by storing the state results or without storing the state results. Correct. Without storing the state results. We store the state results only in DP. So technically, backtracking is also doing what a recursion is doing, and code of backtracking will definitely include recursion. But we are not storing the state results. Instead of that, we are exhausting all the possible states. Exhausting all possible states. Okay. Now, just like we have a trick in terms of DP, we had a template which consists of 4 steps. We will have the same thing here, but instead of 4 steps, it's only going to be simple 2 steps. Okay. So pay your utmost attention here because now we're going to talk about the template for backtracking. Only simple 2 steps. One is to identify whether a question is a backtracking based question, and second is to apply the backtracking. That's it, nothing else. Now, step number 1, identify whether a question can be solved by backtracking. This is important. As I told you, look for the keywords. The keywords will tell you about the intent of the problem statement, okay, and underlying algorithm which is required to solve it. Sometimes, majority of the times, these keywords are very clear. I mean, you look at the problem statement very clearly, they will be asking you what do they want. Sometimes the keywords will be jumbled in the sense it will be made as a story, and you have to read the story and get the essence of the story. What exactly is the requirement? Okay. So, but the second part is not that common, but it can happen in online assessment or in coding contest. You will see sometimes the problem statement is more weaved in terms of a story, so that you have to read it and then you have to make understanding of it, whether it's actually DP or backtracking or brute force or whatever it is. Okay. Now, wherever you find the question and get the intent, like check if is it possible, or whether it can be done or not. Wherever you see such keywords, wherever you find the intuition of the question being asked that you have to exhaust all the possible states, those questions are backtracking questions. Okay. And the answer of those questions are going to be either true or false. Because the answer of this question, it's possible or not, check if it is possible, whether it can be done or not, all of the answers are going to be the true or false, which is backtracking, a binary solution. Okay. So true, false, or yes, no, or possible or not possible. Okay. Now, how do we validate that? Just like we validated in the case of DP also, we are going to validate here as well. Okay. But before, let me quickly revise. Read the problem statement. Sometimes this word will be as it is mentioned in the question. Sometimes you have to read the question, understand the intent of the question. Wherever the intent slash intuition is, you have to exhaust all the possible states. All of those are backtracking these questions. Okay. Let's understand. There's a very common problem called n queens problem. How many of you have solved this? Just answer yes or no if anybody has solved this. Come on, guys, click in the chat. N queens problem. It's a very popular problem. Some of you have, some of you have not, some of you have attempted. Okay, cool, no worries. Irrespective whether you have solved it or not solved it, I'm just going to write down the problem statement and you guys tell me whether it looks like a backtracking question or not. Can you place n queens in a chessboard? This is the most actual version or the original version of the problem statement. You have given 8x8 chess, you have given some n queens, sometimes it is n cross n chess, and you have to check whether you can place n queens in a chessboard. Those who play chess, they would know a queen cannot be placed in the same row or the same column. Okay. Then you have to tell whether you can place n queens in a chessboard. Then there are multiple variations which can be bring on top of this question. But if you read this problem statement, does it give you any intuition that it is a backtracking question? If yes, what is the keyword? Come on, guys, quick in the chat. Which keyword gives you the intuition? Correct. The moment you say, can you place? This itself tells you my output is either going to be true or false. And this statement, can you place, is triggering me to check all possibilities. So whatever that n cross n or 8 cross 8 chessboard, I will try my all the n queens in different variations of this 8 cross 8 or n cross s combination. And then I can comment whether I can place or I cannot place. Until I've explored every possibility or every combination, I cannot say that I cannot, right? So this is the intuition of backtracking questions. Next, another very common problem, which is called the rat in a maze problem, which we are going to solve as well, but rat in a maze problem. How many of you have solved this question? Rat in a maze? Okay. It's okay. There are many variations. There's island version of it and rat in a maze and many versions of it. You will see. We'll solve 8 variations of this question. Even if you have solved it or not, the question is you're given a source, you're given a destination, you're given the direction that you can travel. So imagine a rat is in a matrix and it can travel in certain directions, let's say right and down from current position. There's a source, there's a destination. The problem is, can the rat reach to destination? Now, the output is going to be the true or false. Based upon either if you have solved it or not, based upon this keyword, can you identify whether it's a backtracking question or not? Any keywords which can trigger you? BFS, DFS can be implemented by backtracking also. Okay. All right. Now coming to this, can the rat? Can the rat statement itself very clearly tells you that it is going to be backtracking questions. Underlying algorithm is backtracking. Okay. Now, this is the step number one. Before you even try to solve any question with backtracking, first read the problem statement, either explicitly or implicitly, and make it crystal clear whether that question can be solved by backtracking or not. Once you make the decision that question can be solved by backtracking, then you move to step number two, which is apply backtracking. Now, apply backtracking, it's straightforward, but it requires something. In DP, when we apply DP, we have states. In DP, we used to work with states. In backtracking, there's nothing called state because we are not storing it. So we work with choices. Whatever choices are here, that is what backtracking is for. Okay. So if I say work with choices, what does that mean? There's always going to be two choices at every instance. Either I'm going to include or I'm going to exclude in my combination. Only two choices, include or exclude. Okay. Now let's say my array is 1, 2, 3, 4, 5, 6. And my target is equal to 6. Let's say my current sum is sum of combination. And my need is target minus current sum. Okay. What I need to do is whether I need to include a number in my combination or whether I need to exclude a number in my combination. That's what the problem statement is. That's how you apply the backtracking. Okay. So if I travel left to right in this, let's say I have 1, I decide to include 1. If I decide to include 1, what will happen? Your current sum will become 1. Your need will become 6 minus 1 equal to 5. Okay. Is it like AI backtracking concept try to run on its own with all possible ways? So AI algorithms, when you say run its own, it depends on which particular algorithm you're talking about. Majority of them, 98% of them are heuristic algorithms. Okay. Heuristic versus algorithmic problems are completely different. Heuristic is how closer you can get to a pattern, and any algorithm, be it backtracking, DP, or anything in general, they're not about how closer you can. It's about whether you can get the accurate answer or not. So that's a fundamental difference between heuristic versus non-heuristic algorithm. Anything and everything that you're learning in DSA, at least so far, it's algorithmic statement. None of this is heuristic. You might see some heuristic problem in competitive programming contests, but those are different ways to solve it. Okay. So to answer your question, it's not exactly backtracking, it's more heuristic. Now coming to it, when you move to left to right, Let's say I take the one element, which is 1, I include 1, my current sum becomes 1, my need will become 6 minus 1, which is 5. If I go to next element, I decide to include this. So my current sum would become 1 plus 2, that will become 3. Need will become what? 6 minus 3 now, which is 3. Okay. Now if I go to 1, 2, 3, and I decide that I have to include 3 as well, then my current sum will become 1 plus 2 plus 3, which is 6. And my need will become 6 minus 6, which is going to be 0. Okay. The moment my need becomes 0, that is when I need to stop, because I have found my combination. Remember, the question is not to find all the combination. The question is just to tell whether a combination exists. So the moment you find one combination, you're going to return true from there. Okay. Then you have 1, 2, 4. So I do include 4. Current sum will be 1 plus 2 plus 4. That is going to be 7. And my need is going to be 6 minus 7, which is minus 1. Okay. The moment I got minus 1, that is when I'm going to exclude it. Why? Because my current sum has become greater than target. Okay. So essentially, what did I do? After 1, 2, and I need to pick the next element in my combination, I have two choices. Wherever my next number is 3, first choice, and my next number being 4, that is the second choice. If my next number is 3, I put the current sum as 1 plus 2 plus 3, which is 6. If it is 4, I'll put my current sum as 1 plus 2 plus 4, which is 7. Okay. So my need will become what? My need will become 6 minus 6, which becomes 0. Here my need becomes what? 6 minus 7, which is minus 1. Okay. In this case, I'm going to include it. Why I'm going to include it? Because my current sum is less than equal to target. Here I'm going to exclude it. And why I'm going to exclude it? Because my current sum is greater than target. This part crystal clear to all. Okay. So summarizing, how do you apply backtracking? It's just two parts. One is include and one is exclude. Simple. Very first step, identify it's a backtracking question. Once you identify, then apply backtracking. How do you apply backtracking? Two parts, include, exclude. What happens when you include? When you include a value in combination, number one, my current sum will change to current sum plus new number, and my target would change to target minus current sum. Number two, when you exclude a number or exclude a value in combination, then A, your current sum will not change because it did not include. Similarly, your target will not change because it did not include. Target also not change. Okay. All right, guys. That being said, that's the entire theory of backtracking. Straightforward, two steps. I'll quickly revise it and then we'll move on to the coding questions that we have here. This is technically 8 questions. That's why I've rated as 8 variations. So total 10 questions you can take in total. Okay, quickly revising, what exactly is backtracking? Backtracking is optimization of recursion without storing the state results. How do we do backtracking? We exhaust all the possible states. So simple two steps for backtracking. First, you identify whether the question is actually a backtracking question. Once you have identified that, then you can apply the backtracking. How do you identify that? You check the keywords. If the keyword says check if, is it possible, whether it can be done or not. Wherever the question gives you intuition, we have to exhaust all the possible states. Those are backtracking questions. Okay. Answer is going to be a binary solution, true, false, yes, no, possible, not possible. Those are backtracking questions. In some cases, they can ask you different answers as well. Okay. A good example to understand is n-queen's problem. If you look at the problem statement, it will tell you it is a backtracking question. Same goes for retina maze. The question itself tell you it is a backtracking problem. Okay. Once you identify it's a backtracking problem, that is when you start applying the backtracking. Application of backtracking requires only two things. Either you include or you exclude. In DP, we work with states. In backtracking, we work with choices. And we have only two choices. What do you mean by include or exclude? If I'm going to include something, then my current sum will update and my target will reduce. If I'm going to exclude something, my current sum will not change, my target will not change. Okay. That's the entire theory of backtracking. If everybody clear, quickly give me clear in the chat, then you can start with questions to understand that. Okay. Check sum only for k elements. No, that is not backtracking. Okay. All right. Cool, guys. That being said, let's start with our very first problem statement, which is a very important question in backtracking, and then we'll take it from there. Question number one, I'm taking it as it is. This has been asked in Amazon, but this has been asked in a lot of companies. Dr. Cuckoo's pack of hands, it has been asked in Google, Cisco, Apple, and many, many other companies. Let me take this question as very important. Okay. I'm going to give you the exact problem which was asked in online assessment, and then we can start solving it. Its variation would be present on multiple platforms, but let me find the exact problem which was asked in online assessment. All right. This is the exact problem statement. Let's go through it one by one. So you're given a problem statement. Dr. Cuckoo has a pack of hens, each laying some eggs. She represents the eggs laid by each hen in an array. Like, let me scroll like this. So first hen is given 1, second 7, 2, 0, 5, 6. It's commonly understood. This array does not contain negative values. Common sense, right? Given a goal of x, we want to know if there are hens which, when summed, give the exact goal required. For example, for a goal of 3, it is possible in the above array, but a goal of 4 is not. Okay. Write a method bet that takes 3 parameters, integer array that contains the accurate by hens, and second, with the value of goal. You have to return value of Boolean value of true if the goal can be reached or false if it cannot be reached. The met method is to be defined inside solution class. That is fine. You can define the other methods, Google for backtracking algorithm and recursion, and this is the input. Let's come to the input. So I'm given 2, 4, and 8. Can I make 14 out of 2, 4, and 8? Answer is I can. So output becomes true. Next is 10 to 15. Can I make 9 using 10 to 15? Any combination of sum of 10 to 15? Come on, guys, quick in the chat. Repetition is not allowed here. The eggs which are laid by a hen, you can use only once. So repetition is not allowed. Can you make 9 using 10 to 15? You cannot. The other you can do is 5 plus 2 plus 1, which is 8, but not 9. 10 to 15, 20, even if you take sum of all the values, that is still 18, so output becomes false. This is the function that you have to complete in Python. You're given the first value as the x, which is an array, second integer. In Java, you're given to complete this function met, where integer array x is given and the goal is given. Okay. All right, guys. Isn't this the same problem as we discussed before? Any combination sum? Yes or no? Same problem which we discussed here. Any combination sum? Correct. This is the same problem. This is called subset sum problem. No, not two sum. It's a subset sum problem. It can be any combination, not two values. It can be 10 values, 1,000 values, whatever it is. That's why I said it's a very, very important question. It has been asked in many companies. Variation has been asked in many companies and will be asked in many companies. It's a good question to solve. But anyways, everybody crystal clear with the problem statement first. Anybody has any doubt in understanding the requirement of the question? Okay. If the problem statement is clear, I want to give you time, give you guys time instead of me directly solving it. My piece of advice, try to solve it by template. The question would become much easier. Okay, even if you have solved it before, not solved it before, try to solve it by template. The question would become much easier. Okay, what is the template? Simple two steps. Number one, identify whether it is actually a backtracking question. And number two, apply the backtracking. For number two, I'm just giving you in the notes. This is what you mean by applying the backtracking. But that being said, do not take too much time on it because we have multiple questions to cover too. So I'm going to time box it to next 5 or 6 minutes. Try this question. How do you want to do it? And if you're able to solve well and good, I'm giving you the Python function and respective Java function to complete. This is the function that you have to complete. Remember, you have to return a Boolean, which is returning true or false, whether you're able to achieve that or you're not able to achieve it. Okay. Do mention time and space complexity in your code and change your message directly to me, do not message to everyone. Once you guys are done, please let me know in the chat for discussion and then we can start the discussion. Everybody clear with the instructions? Anyone who is not clear with any requirement, please let me know. Okay, cool. If all good, I give you time to you guys. Let me know once you guys are done, then we'll have a discussion. Your time starts now. Okay, let me give the example input. So you can ignore this value of 0. You don't need to worry about it. That was given in the online assessment specifically. So in your function, you'll be given two inputs. One is an integer array, one is an integer number. So integer array is denoting the integer array, which is the number of x laid by each hand, and this is the goal that you have to achieve. So for example, 10 to 1, 5. Can you make 20 by sum of 10 to 1, 5? You cannot. So output become false. Similarly, can you make 9 using sum of 10 to 1, 5? No, so output false. Can you make 14 using sum of 2, 4, 8? You can, output true. That's what the question is. Okay. I'll keep the screen on the question in case anybody wants to. Function what I have to complete, I've already given. Okay. Keep me posted, guys, once you guys are done. Do not take too much time on it, and then we can start the discussion. And guys, are we good to discuss? Cool. If we're good to discuss, let's start the solution now. We'll go to the template. That will be much easier for everyone to compare. And one moment. Cool. Yeah, we'll discuss that. Let's go to the template real quick, and then we'll try to implement it. Step number 1 in the template is identify whether it's actually a backtracking based question or not. Once we're done with that, then we're going to actually apply backtracking. Okay, let's start with the step number 1, which is identify. How do we identify? Look at the problem statement. Tell me the keywords or set of keywords where you think the question tells you it can be solved by backtracking. Quickly in the chat. Come on, guys. In the problem statement, which keyword or set of keywords tells you it is a backtracking question? You can answer to everyone, guys. Correct. See, in general, let me give you a very simple hack or trick or whatever you want to call. In general, whenever you're solving any online assessment question or coding contest question, majority of the time, whatever is the crux of the question, sometimes you'll find a question, especially on platforms like Codeforces or HackerRank, you'll find a question is very big. You don't need to spend too much time to read all the questions and get through it. Read it if you have time. But if you're really competing against your time, more likely or not, 99% of the time, wherever your function talks about what you have to return, that is where the crux of question is given. So even if I skip all of these lines, I'm not saying you should, but even if I skip all these lines because I'm running short, I would start reading the question from here. What are the question says? You have to return a Boolean value of true if the goal can be reached or it cannot be reached. By reading this one line, can I understand the question, yes or no? If I don't read the entire question, but I just read this line, that also is sufficient. You can spend time reading the entire question, seeing about what is a hen, what is an egg, or you can just read this line and you can understand what the question is asking. So a simple trick, wherever the function talks about for returning it, start reading from there, read the fine lines, and then you will understand what the question is talking about. Okay. This itself tells you very clearly it's a backtracking based question. Number 1. Number 2, if you want to go actually read the question, this part of the question, if there are hands which summed give the exact code required, they both very clearly tells you this can be identified as a backtracking based problem. Everybody crystal clear with this? Quick in the chat, guys. All clear? Cool. Now the second part is how do you apply the backtracking? So now to apply the backtracking, there are two ways. Either you include or you exclude. So you take this part, you come to here. Either you're going to include it or you're going to exclude it. Now, in these cases, we need to talk about what are the cases which are possible. We are going to talk about target equal to target minus current sum, right? This is going to be, what can be the edge cases before we run any backtracking code? Let's talk about the edge cases. Number 1, if my target equal to 0, I'm going to return true because I have found a combination. Number 2, if my index is greater than equal to length of array, greater than equal to length of array. Can I go more than the length of array? No. So I have to return false. Number 3, if my target becomes negative, my target becomes negative means my current sum becomes greater than target. So if a current sum becomes greater than target, that is an invalid combination. Okay. And that is when you return false. Everybody crystal clear with the base cases. Target becomes 0, you found the answer, return true. You cannot go outside the index, and if target becomes negative, means your current sum becomes greater than target, you return false. These base conditions clear to all. Come on, guys, quick in the chat. These are just the base conditions. Cool. Apart from this base condition, next part is the actual backtracking, where it will involve two possibilities. What are the two possibilities? Either you are going to include or you are going to exclude. So when you say include, let's call this function as solve or whatever you want to do it. I will move to the next index because I anyways have to move to the next index. If I include, my target will become target minus that value. If I exclude, I still will move to the next index, but will my target change? If I've excluded something from my combination, will my target change? No, my target will still remain target. Okay. If I included it, my target will get reduced and move to next. If I have excluded it, my target remains same and then you move to next. Everybody crystal clear with this part. Simple code, simple possibilities. First you write the base conditions and then you actually implement the backtracking. Any doubt, any questions? Easy? Okay. If it is easy, let's try to quickly write down the code. Maybe I can take it on lead code specifically. And then we can start writing the code and we can verify the rest cases. So let me take you guys to lead code real quick. And we can write down the code to verify that. This is lead code. You guys can see my screen. All good. Cool. Let's code it real quick in Python. Will save us time. What do we need? First thing, what do we need is we need a numbers. Let's call it as 2, 4, 8. We need a target. Let's call it as 14. What is expected output? Expected output is true here. Okay. Let's define a function from some combination or something. Find some combination, something like that. What do I need? I need array, I need index, and what do you want? I need the target. Okay. So first thing first, what we are going to do? Base case. The three base case we talked about. If my target becomes equal to 0, if a target becomes equal to 0, what do? You return true. Okay. If your target becomes negative or your index become greater than equal to length of array, what do you return? False. Now, two possibilities. Look at this Python, so two possibilities. What's the first possibility? If I'm going to include it, means find some combination. Now what? Index plus 1, array comma index plus 1, and target minus array of index. Okay. This is try including the current element. Same line, copy it, try excluding the current element. So this will become exclude. Only difference is now the target will remain target only. Okay. What do I need to do? That is the most important part. At this moment, once you have calculated include or exclude, you are going to return include or exclude. I'll talk about why did I say include or exclude once we're done with this. Okay. So let's take this guy. Let's try to print it. Str. Find some combination. What am I given here? I'm given as numbers. I'll start with 0. I'll move to target. Okay. This is good. Dot load. That will print in the load case. Okay. I think this code should do. Base condition is this. Base condition is fine. Include, exclude, find some combination. Let's run the code. Output is true, which is correct. Let's verify for other cases also. Yeah, it is recursion, right? This is the function. We are calling the function inside it. Backtracking is recursion. It's implemented by recursion only. Okay. Now what else? Let's verify some more test cases. Test case number 2 was what? 10, 2, 1 and 5, and output is 9. Let's verify one more test case. So we'll be 100% sure. One moment. 10, 2, 1, 5 with 9, 10, 2, 1, 5 with 20. I'll take your test case. 10, 10, 1, 10. Okay, I'll replace it. So if you can take 10, 1, 10, 10. So you have 30. That should be possible. Okay, cool. Let's clear it. Let's run the code. Let's verify our output. First condition, are we able to make 14 out of 2, 4, and 8? We can. So the output is true. Second, can we make 9 out of 10 to 1, 5? No. So the output is false. Third, can we make 20 out of 10 to 1, 5? No. So the output is false. Can we make 30 out of this? 10 plus 10 plus 10. Output is true. Okay. So our code is working fine. It will work on all test cases. Okay. Now, before we move to anything else, what's the difference in recursion and backtracking? That's what I'm coming to. See, backtracking is implemented by recursion. If you ask me like in terms of code perspective, is the difference? There is no difference. DFS is implemented by recursion. So if you ask me code perspective, DFS recursion are different? No. The intent which they are applied is very different. Okay. The way backtracking works is you have to check for all possibilities, whether you can get the answer or not get the answer. Okay. The way DFS work is you have to go to the depth of every node and check whether whatever you're looking for is found or not. Okay. So if you just look from code perspective, you will say that these algorithms are same. And recursion is a way of implementing things. Recursion is not a base algorithm like backtracking itself. Okay. So we use recursion to implement the backtracking, but the intent of backtracking is to explore all the possibilities. Okay. Now let's understand one by one. I'll take one example, then you can move on to other test cases also. We can store the state of DP of index and target. You can and you cannot, but my recommendation is solve this question by backtracking specifically because it's a clear-cut backtracking question. You can convert into a DP problem solution. You can check whether it exists or does not exist, and then you can return it. But this is a very clear backtracking this question, and the expectation is by backtracking also. Okay, that is why you will see the constraints would be very less. But anyways, coming to it, let's take for this test case, and you can similarly extend for the test case. There's something very interesting which is happening here. What is happening here is once you pass 2, 4, 8 and you pass the target 14, I don't think anybody has any doubt between these three base cases. So I will not spend time here. If everybody is clear, I can move to the important part. Come on guys, give me confirmation in the chat. Base conditions are clear to everyone, so I can move on to the important part. Okay, no doubts, no questions. Cool. Important part is just 2 lines of code, technically 3 lines of code. One line of code is talking about what if I include the current element. Second is what if I exclude the current element. And third is important, which is include or exclude. I'll talk about that. When you say include the element, you're going to recur on it. You will move on to the next element. And since you have included the current element, my target will become target minus array of index. Anybody, any question in line number 11? When you include the current element, you will still move on to the next element. It's just that your target is now reduced to target minus that element because you have included that element. Anybody, any question at line 11? All good? Cool. Line 14 now. In line 14, I'm still going to move to the next element because I have to explore all the possibilities. So it's not like I will not explore after it. I will explore all possibilities, but since the current element is not included or excluded, my target will remain the same. Everyone clear with this? Come on guys, quick in the chat. What are we doing? Okay, let me repeat it. Same thing we have discussed in terms of how to apply backtracking, but let me explain again. The way you implement backtracking is simple, two steps. Either you include it or you exclude it. Once you include it, your target will reduce to target minus current sum. And once you exclude it, your target will remain same. If I include the current number that I have in the array, I will still explore the possibilities. So if you see, I will go to index plus one and include, or I'll go to index plus one and exclude. We have to go to index plus one for sure. The only difference is if I included the current number in my combination, now the target that I'm looking for becomes target minus array index. What does that mean? Let's say my current is 2. Now what I'm looking is 14 minus 2. Agree? If I already have 2, what I'll be looking is 14 minus 2. Correct? If I exclude from the combination, my target will remain target. If I do not include 2, I will searching for 14 again. This part clear to all guys. We discussed this in the apply backtracking section. Quick in the chat guys. I thought this is the easier part. I don't know why it's taking so much long. Everybody clear with this? There's nothing confusing or issue here. Cool. These two are include and exclude. The important part is line number 16. Why did I write include or exclude? Why didn't I just return include? Why didn't I just return exclude? Why did I write include or exclude? Anybody can tell me. Come on guys, quick in the chat. Line number 16 is actually the most interesting part of this code. Rest of the code is very simple. Why did I return include or exclude? Why did not I return maybe just include or maybe just exclude? 10 seconds, quick in the chat. Either cases true, sum is possible, else not. Target sum may come from include or exclude. Okay. Anybody else? Okay. Cool. Let's understand this small line number 16, which is the actual code that you need to understand. The rest of the code is straightforward. Let's go back to our Sublime text, which is where we are. Just close your Sublime text. Now, this is Python, so it would have got some formatting, but it's fine. This is input. You can have the output. What's the output? True, false, false, true. All good. Okay. The important part here. Important part when I say I'm going to return include or exclude, what does that part means first? Understand this via tree diagram. What you're checking is when you say I'm going to include or exclude, at every step you're checking two possibilities. Whether you can get the answer by including or by excluding. Agree? When you say return or exclude, that means you are checking two possibilities. Either you can get the answer by including it or by excluding it. At every step, check for two possibilities. One with include and one with exclude for all numbers. Okay. Means you have to exhaust all possible states. And that what qualifies this question as backtracking. Okay. Let's understand this. How does the tree diagram looks like with an example? You have 2 for 8 and your target was 14. That was the problem statement. Okay. Let's see how the diagram will look like. If I start from, let's say 2. 2 is my root. Now there are two possibilities. Once I go to 2, the next element is 4. Agree? Once the next element is 4, there are two possibilities. Either I can include 4 or I can exclude 4. So 6, if I include 4, and it remains 2 if I don't include 4. All agree? This is what you mean by include or exclude. You are at 2, you move to the next element. Now there are two possibilities. Either you can include it or you can exclude it. If I include it, 2 plus 4 will become 6. If I don't include it, 2 will remain 2. Come on guys, quick in the chat. Cool. Same thing for the next element. Every step will follow the same path. So once you move to 6, now the next element is 8. Again, you got two choices. Either you can include it or you can exclude it. So if I include it, what will that become? That will become 2 plus 6 plus 8, that is 14. If I exclude it, that will remain 6 as it is. Similarly, if I talk about 8 here, if I include it, that will become 10. If I exclude it, that will still remain 2. Everybody crystal clear with this tree diagram? Yes or no? Anybody has any doubt in this tree diagram? At every step, we have two possibilities, either you include it or you exclude it. And with those possibilities, this is the tree diagram that you will have. Okay. Quick in the chat, guys. Okay. Once you understand this tree diagram, now what the question is? The question is only asking you one thing. That target that you are looking to find, that target can only be found out in one of these nodes. So I can make 2 from this combination. Yes. I can make 6 from this combination. Yes. I can make 2 obviously again. I can make 14 from this combination. Yes. I can make 10 from this combination. Yes. Okay. Everybody clear with this part? This is what the problem statement is. So when you say, can I make 14 or not? There can be possibilities. Either you have to include a number or you have to exclude a number. For example, if I have to make 10, then I have to take a sum of 2 and 8. I have to exclude the 4 part here. Okay. So how would you check that? You have to take sum of or condition of include or exclude. A value can be found by including something or excluding something. That is the part I return this code, include or exclude. Everybody crystal clear with this? Come on guys, click in the chat. Everybody crystal clear with this? Good. If this is clear, let's clear it. Let's come back here. Find all combinations and return target exist or not. Find all combinations sum. What do you think would be the complexity of that? Think about it, then we can talk. Anyways, coming back to time complexity of this code, this you can see at every moment we have two choices. Either you're going to include it or you're going to exclude it. So branches raised to the power depth, 2 raised to the power n, space quantity big of n, which is the auxiliary space for recursion stack. Okay. All right, this is your subset sum problem. Simple 4 lines of code. I mean, base conditions I'm not counting. 1, 2, 3 lines of code, technically you can say. And it's a very, very useful and important question. And you will find many variations of this question across different platforms. Okay. But question is pretty straightforward. Why is a backtracking question? How do you solve backtracking question? What's the condition of include exclude? How do you implement the include exclude? How do you identify backtracking and how do you implement backtracking? All of those parts would be covered here. So I'm marking this as done. Can we do a dry run? This is a dry run technically. Look at this. This part is dry run. Once you go to 2, and during 2, what you're doing is you're going to either 6 or you're moving to 2. And every part that you're either including or excluding. So 2 plus 6 plus 8, if I include 8, that becomes 4. If I don't include 8, that will become remain 6. Similarly, for 2, if I include 8, it will become 10. If I exclude 8, it will remain 2 as it is. This part is the dry run. Okay. All right, guys. This was a very good question, easier question, but important to understand how backtracking works. Second question is a difficult question. Third question is again easier to not easier. It has 8 variations, so easy, medium to hard questions. But second one is a hard question, but let's take this question first. Question number 2, we'll solve this question on lead code to save us time. I'll give you the exact question which was asked, but then I can save you the question which is available on read code. Both are same questions, by the way, just the language would change. The question which was asked in online assessment is this. Let me get it here. Then also let me get the problem on lead code as well. Good. Anyways, let's come back here. There we go. This was the online assessment problem. Okay. And the reason this problem is tough is not because of implementation of backtracking. This problem is tough because of the language. Majority of the time, candidates are not able to understand the problem because of the nature of the language of this problem. But once you understand this question is good. It's not super hard question. It's a good medium to hard level question, but it requires multiple levels to solve a question. There are multiple sub questions as part of this question. The question is not super complicated, requiring some advanced level DSL go, but this question requires some very good coverage of edge cases of functional testing. Okay, let's read the problem statement first, and then we'll talk about solution. Then we can take the lead code problem as well. The problem statement says, given an array of distinct integers array, what is distinct integers? Quickly in the chat, guys. Distinct integer means unique values, and a target integer target. Return a list of all unique combinations. Remember, you have to return a list of all unique combinations of array where the chosen number sum to target. The same number may be chosen from candidates an unlimited number of times. The combinations are unique if the frequency of at least one of the chosen number is different. Okay. All numbers, including target, will be positive integers. Elements in a combination must be in non-decreasing order. Non-decreasing order means increasing order. Combination themselves must be sorted in ascending order. Combination A is greater than combination B if A1 is greater than B1, or if A1 is equal to B1 and A2 is greater than B2, and so on and so forth. Solution set must not contain duplicate combinations. You are given first line n, denoting the size of the array. The second line contains space separated integers, denoting the elements of array. Third line contains the target value 47265, and then you have to print the output of it. Okay. Tell me honestly, how many of you understood the question? If you don't, just type no in the chat. Cool. 90% say no, because as I said, the problem is not super complex in terms of algorithms or data structures, but the problem is complex in terms of language. You have to decipher each and every requirement of the question, then only you can understand this question and solve it. Okay, and pass all the test cases. So first thing first, take out this section separately, then read the problem statement. It will become easier, slightly easier. If this problem is asked, this is going to be the only problem to be asked, until unless it's an extremely good candidate. In such cases, we do ask a second follow-up. But generally, if we ask this problem, it's going to be only one problem in 45 minutes, because then they can go to each and every edge case and they can talk about it, they can give the solution and then write the code for it. Okay. So this is one of those problems. If it is asked, it's the only problem in 45 minutes. Okay. Now let's take these combinations out, then we'll talk about it. Understanding of the problem. These are the conditions. Okay. First thing first, there was a statement says if. This if condition. What does this IFF means? Anyone knows? You would have studied in mathematics, guys. What does this IFF means? Yeah. Is it a typo in if? Correct. It's not a typo. This IFF means if and only if. If and only if. Okay. Now let's start reading the problem statement. Where do we start reading? We start reading from here. Array of distinct integers is given. We understand array will contain unique elements, which it does contain. In the simple test case, array contain unique elements. Okay. Return a list of all unique combinations of array. So Take this part. Return a list of all combinations, unique combinations of an array where the chosen numbers sum up to target. Copy this if it was not copied properly. Where the sum of chosen numbers becomes equal to target. Okay, now coming to this part. So first thing first, one combination is going to be an array. Agree? One combination is going to be an array. Yes or no? When you make one combination where the sum will become equal to target. Look in the chat, guys. Read this statement again if anything is not clear. Return a list of all unique combinations of array where the chosen number sum to target. Means my one combination will be choosing to target. So if you look at this part, if my sum is 16, 2, 2, 2 up to 8 times is giving me 16. So my one combination is going to be an array. Agree? Okay. What is this asking me to return? It is asking me to return all unique combinations. So what is my final answer? My final answer is not going to be a 1D array. It's going to be a 2D array. Vector of vectors, list of list, or 2D array, whatever you want to call it. 2D array. My answer would be something like combination 1, combination 2, etc. etc. C1 is combination 1, C2 is combination 2. All agree? Come on, guys, quick in the chat. We have to solve a lot of questions. The first line of the statement is very clear. I have to return a list of all unique combinations where every combination will sum equal to target. Means the final answer that I'll be returning, I'll not be returning a 1D array. I'll be returning a 2D array. And that's what you see in the output as well. This is a 2D array. List of list, vector of vector, whatever you want to call. Now, what next? Then I'm given some conditions. Let's talk about the conditions one by one. All numbers, including the target, will be positive integers. Do we need any follow-up on it? Do we need any follow-up? No. The question itself, this condition itself very clear. All numbers will be positive integers. Okay. Next. Elements in a combination must be in non-decreasing order. What does that mean? What does that mean? Elements in a combination must be in non-decreasing order. Let's talk about this condition. When you say elements in an order has to be in non-decreasing condition, means this has to be row-wise sorted. Your C1, C2 inside my C1 and inside my C2, it has to be increasing order. Inside one combination, it has to be in increasing order. Okay. So if you look at this, this is increasing order, this is increasing order, this is increasing order, this is increasing order, everything is increasing order. Elements in a combination means inside a combination must be in ascending order. Everybody crystal clear with this condition. Quickly in the chat, guys. In one combination, the element should be in ascending order. Okay. Next, the combination themselves must be sorted in ascending order. This is another important. What does this part mean? That the combination themselves must be sorted in ascending order. It means it has to be column-wise sorted where C1 is less than C2 is less than C3. It is a increasing order of combination. Okay. C1 is your first combination, C2 is second, C3 is third. It's increasing order of combination. Now, the question becomes between a combination, like inside a combination, you can compare whichever is increasing order. How do you compare between combination? Means how would you compare between two arrays? Inside array, you can tell which one is lower, which one is lower based upon the value. Inside two arrays or between two arrays, how do you compare which one is smaller, which one is greater? That is the next condition. Combination A, how do you compare between the combination? They have given the part here. Combination A is greater than combination B if A1 is greater than B1. If A1 is equal to B1, then you go to A2. If both are same, then you go to A3, so on and so forth. Means what do you do? 1, 2, 3 and 2, 3, 4. We already know the combinations are sorted. Okay. So if we talk about 1, 2, 3 and 2, 3, 4, we'll compare with the first value. Since 1 is less than 2, I will claim that this combination is less than this combination. Everybody, crystal clear? Come on guys, quick in the chat. How do you compare between two combination? Is that what we are discussing right now? So what the condition is given is, since both of them are sorted, you compare the first element. If first element, whichever is smaller, you will claim that combination is smaller. Everybody clear with this? Quick in the chat, guys. Okay, cool. What happens if the first element is same? So if the first element is same, they've given the condition, then you check the second element. So if I have 1, 2, 3, and let's say 1, 5, 6, what do I do now? First element same, now I go to second element, 2 is less than 5, so we will compare this combination is less than this combination. Similarly, if second element is also same, check for third, fourth, fifth, sixth, etc., etc. That's the condition they have given us. Okay. What next? The solution set must not contain duplicate combinations. Okay, let's write it down. When you say solution set must not contain duplicate combinations, means I would have only unique values. Combinations must be unique, but so between two combinations, repetition is not allowed. If I check between two combination, I cannot have two repeated combination in my answer. Repetition is not allowed. But there was one more statement which is given here. The same number can be chosen from candidates an unlimited number of times. So what is this telling? When you say same number can be chosen for unlimited number of times, inside a combination, repetition is allowed. Okay. So if I'm talking about inside one combination, I can use a one number infinite number of times. But if I talk about my final answer, which is my 2D array, I cannot repeat two combination. Is this part crystal clear to all? Come on guys, quick in the chat. Okay. Once you're clear with these conditions, now we can talk about the sample test case. Now you will understand the question one by one. Okay. But before I go there, I'll quickly revise this understanding again in case as anybody has missed anything. Please focus your attention here. I'm repeating it again. This question is hard. There is no doubt about it. But this question is not hard from algorithm perspective. This question is hard in terms of functionality perspective. If you miss any of the condition, you will not be able to pass all the test case. As an interviewer, I have seen majority of the candidates are able to write code, but they are missing conditions. So their code is not sufficient enough to pass all the test case. Your requirement is your code should be functionally correct. Don't worry, you will have enough time, 45 minutes to solve this question, but make sure you're understanding all the requirements properly. If you do not, your code will not pass all test cases. Okay. So first thing first, where you should start this question is start from this part where is this condition given, and that will help you decipher the question what exactly the requirements are. First thing first, my function wants me to return a list of all unique combination where the chosen number sum equal to target. Okay. So when you say list of unique combinations, one combination itself is array. When you say list of combination, you're talking about a 2D array. So my final answer is going to be vector of vectors, list of list 2D array. Okay. That's number one. Number two, element in a combination must be non-decreasing order. Means inside one combination, the element should be in increasing order. Easy. Number three, the combination themselves must be sorted in ascending order. Means two arrays should be also in ascending order. Now inside array, I know how to take the maximum value. How do you take the smaller value and bigger value? How you can make it ascending. But inside between the two arrays, now you need to compare. They needs to be sorted. How do you compare between the two arrays? That's the part they have given. What you do is between the two arrays, if you have to compare, you compare the first element. If the first element is smaller, that combination will be smaller. If first element is same, then you compare the second element. If first two elements, compare third. First 10 elements, compare 11, so on and so forth. Solution must not contain duplicate combinations. Means I cannot take two combinations in two same combinations in my answer. Between two combinations, repetition is not allowed. Same number may be chosen from unlimited times. Inside a combination, repetition is allowed. Okay. These are the rules and conditions of this question. I've explained each and every word, each and every line with example. Everybody crystal clear with this? Then I'll move to the code part or example part. Come on, guys, quick in the chat. Okay. Now we can start with example input and example output to understand this better. Okay, cool. When it's example input, example output, let's talk about this part first of all. We have to take one element in a combination. I can take infinite number of times, but I cannot repeat the combination. What do you mean by that? Repeat the combination? This 5 times 2 and 6, it's going to be only one possibility which can exist. I cannot repeat this combination. How do you get that? Let's talk about it. 5 times 2, 1 times 6. If you guys remember, we discussed the formula where number of ways or arrangements from n values where r are repeated. What's the formula? Quick in the chat. I told you it in last 2-3 classes or something. Correct. The formula is n factorial by r factorial. So if you have 5 times 2 and 1 times 6, what's the answer? 6 factorial divided by 5 factorial, which is 6. That is mathematically how you can prove it. If you want to use common sense, you can use common sense also. If you have to make combinations or all permutations of this, how will you do it? Only 6 is the one which has vary. So you just change the condition of 6 or place of 6 every time. So copy this, paste, 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 paste. 1, 2, 3, 4, 5, 6. Make 6 here. Make 6 here. All agree with this. All agree with this. Quick in the chat. These are the 6 permutations which can exist. Now, what did we talk about? We will not have duplicate combination. Means only one of these will be selected in my answer. And which one will be selected? The one with the ascending order. Okay. So out of 6 permutations, only one which is in the ascending order, and there can be only one in the ascending order, will be in final answer. Okay. And same goes for every other permutation also. I've just taken this example, but same goes for every other permutation also. They all have to be sorted if you can check. Now tell me if the problem is crystal clear to everyone. Any doubts, any questions, please let me know. But I believe now the problem should be crystal clear to everyone. Come on, let's begin the chat. The only thing which is complicated in this question is the language of the question, and you need to be very clear in understanding what the requirements are. Once you decipher everything, you will understand what needs to be solved. Okay. But even if you know what needs to be solved, it's still not an easy question to solve. Okay. So if you have not solved it, very unlikely that you will be able to solve within that short window. So such kind of questions you have to practice in advance. Reading comprehension is important. A lot of things are important. Even if you have understood the problem by now, let's say you spend 15 minutes and you are very clear with the problem, still you have to come up with some good knowledge of data structure algorithm to solve this problem. Okay. Let's get this problem on lead code so everybody can try it at least. And then we can take it. So I think this is, it has variation on lead code as well. Maybe the direct question is also there. Let me find out. Let's solve this. Yep, it's on lead code. Cool. Let's get this question. All right. Let me change the function. All right. All right. You guys should be able to see my lead code screen now. This is what the question on lead code. Okay. First thing first, if you look at the stats, 3.5 million submission. And if you look at the companies, I think the number of likes is what, 20.1 thousand. The number of companies which have asked this question, you can see all the major product-based companies have asked this question quite recently. Okay. Now, what is the problem statement? Given an array of distinct integers candidates and a target integer target, return a list of all unique combination of candidates where the chosen number sum to target. You may return the answer in any order. Same number may be chosen from candidates unlimited number of time. Two combinations are unique if frequency of this exactly the same wordings. Test key the generator such that the number of unique combinations sum up to target is less than 150 combinations for given input. Okay, so you can easily apply backtracking. Nothing to worry about it. 2367 target equal to 7. They have given us the combination that you can make 2, 2, 3 and 7. Okay. 235 target equal to 8. So you can use 2 4 times. You can use 2, 3, 3. You can use 3, 5. Again, all of them are sorted order. 2, 2, 3 sorted. 2, 2, 2, 2 and 2, 3, 3, 3, 5 all sorted. Okay, 7 already sorted. From 2, you cannot make target equal to 1, so you return an empty. Remember, it's a 2D array. Candidate's length is up to 30. Candidate's value is between 2 to 40. I told you, constraints will be very small if you have to apply backtracking. All elements of candidates are already given as distinct and target will be up to 40 only. Let me take this. This is the lead code version of this. Go back to Sublime. I'll create a placeholder here. This is for my question number 2 only. Lead code 439, combination sum. There you go. Okay. Example 1, example 2, example 3. And the function that is required, where is this? You are returning a list of list. You're given integer array candidates, you're given a target. Okay. Anything else required? Okay, all good. We got the link already. All right, guys. We got the lead code variation. I've explained you the problem already in detail. This was the question which was asked in online assessment. This was the exact question which is there in lead code as well. Constraints are a bit different. The values were up to 50 and 60. Here it is up to 30 and 40, which is fine. Won't make much difference. Okay. But that being said, everybody crystal clear. Same problem is there on lead code. And I'm taking the lead code because you guys can solve and test your code there. All good? Good. If everything is good, this is your function that you have to complete. Feel free to code it in Java or any language of your choice, whichever you feel most comfortable. And this is the lead code problem link where you have to submit. Once you guys are done, share me the submission link and then we can go for discussion. Please do mention time and space complexity along with your code. It's completely fine if you're not able to pass all test cases. If you are not, please do mention how many test cases you are able to pass. Okay. All right, guys. This is your problem statement. Before I give you your time, anybody has any questions? Before I give you time, anybody has any questions? All good? Cool. Well, guys, then all up to you. Please change your mind directly to me. Do not message to everyone and let me know once you guys are ready for discussion. Be mindful of time. This question will require time to code and understand everything. So do not take too much time for solving. Your time starts now. All right, guys. Are we good to discuss now? Quick in the chat. Are we good to discuss? Cool. If we're good to discuss, let's quickly start the discussion. Anyone who is able to pass all the test cases? Okay, some of you are, some of you are not. Cool, no worries. Let's start the discussion. Let's see. First thing first, we have a couple of things to talk about in this question. First thing is, when we talk about, we need to get a sorted answer in terms of a list, in terms of my list answer. What is the easiest way I can do it? One way is that I can make a list of all the combination and then I can sort it. That's a valid way. Another way is, before even going for backtracking, if I sort the array initially, original array which is given to me, before even applying the backtracking, will it not get me sorted permutations? Yes or no? Quick in the chat. I need the sorted permutations. One way is that I can get all the combination and then I can sort them individually. Or another way is, if I sort the array initially and if I do a backtracking on a sorted permutation, I will always get the sorted combinations. Yes or no? Backtracking on a sorted array will give me sorted permutation. Yes or no? Quick in the chat. Come on guys, quick in the chat. When you move to index plus 1, you'll always move into a next value. Backtracking in a sorted array will give me sorted permutations. That's all. Index plus 1. Easy. Okay. Second, we need unique values. So to find the unique values or distinct values, I can use a data structure, which we call as set. Okay. What else? The third part is actually apply the backtracking. So how are you going to apply the backtracking? I'm going to apply the backtracking. Let's divide the case again. Case number 1, if my target becomes equal to 0. Target becomes equal to 0 means I have found my combination. If I find my combination, I'm going to return true. Should I return true if I found a combination? Come on guys, quick in the chat. No, I should not. I make a list of all the combinations. So instead of returning true, I will add that to my answer, which is list of combinations. What else? Case number 2. Case number 2 is if your target is negative. What happens if your target is negative? My current sum becomes greater than target. I am going to ignore that case and load into my answer, which is list of combinations. And then final part is case 3. What is case 3? If your target is greater than 0, what do? Means your current sum is less than target. Then you can insert the present array and backtrack. And when you backtrack, two possibilities. Select, my target will become target minus array of 5. If I not select, then what will happen? Target will remain target. No change. Everybody crystal clear with this part? Quick in the chat, guys. Simple. In terms of like backtracking, first we have the base condition. Base condition number 1, the moment you find target becomes 0 means you have found a combination. Now I don't need to return true here because I need to make a list of all the combinations. Number 2, if target becomes negative means current sum become greater than target, I can simply ignore that case. I will continue with the finding other combinations. Case number 3, if target is positive means I've still not reached to the target. I've still not found my combination. So I'll backtrack. I'll still go with the select or not select to basically include or exclude. Everybody crystal clear with this? Quick in the chat, guys. Then we can start the code part. Define the base condition. Talk about the cases for include, exclude. Defining the condition, what you need to do. That's all. Ultimately, backtracking is just about these two lines, 661 and 663. Okay. If this is good, let's move on to the code part and then we can talk more about code. Let me code for the online assessment problem, and then we'll code for the next parts. Let's take it here. All right, the input that we have is this. Just a moment. Let me get back to the question. Okay, cool. Let's come back here, then we'll discuss about it. How this optimize our recursion? Final output is not in binary format. What is that intuition gives you backtracking? Good question. See, what's the intuition behind backtracking? Let's come back to this problem statement. If you look at this, what the question is asking about is return a list of all unique combinations. Whenever it is talking about giving you intuition, you have to explore all the possibilities. That itself tells you it's a backtracking question. Okay. Binary or not binary, that is subjective. It not always has to be a binary equivalent. It does not always has to be true or false. Sometimes they can ask you to print all the combinations. But the intuition of printing all the unique combination, that tells you have to go by backtracking. Okay. Cool. Let me format this code because this is in Python and we might be missing some of the indentation. So let me correct this real quick. So this is a function we have to complete. This is backtrack. Let's start with the input. We got an equal to integer, list of this, sum equal to input, combination sum. This is good. Now enter backtrack code. If target becomes 0, ignore that. Target equal to 0. Let's add it to our condition. This is my final answer to the list. This is my combination. And what else? Just the indentation I need to be 100% clear with. For I in range. Okay, this 4 is correct. I'm going to backtrack this, and that gives my function. Cool. This indentation looks good to me. Now what do you have? Your combination sum, your given candidates and target. This is the function I'll be calling. I define my final answer. I define my candidate sorted. I'm converting it into a set. I print the combinations. Print size this. Okay, now I think it should work. Inconsistent use of tabs and spaces. Return final answer. Line number 8. Line number 8. We are missing something in indentation. Okay, let's see. Extra space is there. Here, like before return or after return. Okay, it says line number 8, there is some extra space in indentation. So that's why I use, like in Python, I use the editors. But let's see. Yep. All right, size equal to 7, combination this. Now let's go step by step what is happening here. Okay. Majorly, two parts of this question once you have understood the problem. One, if you need the sorted permutation, sorted combinations, you need to have the sorted array first. Number two, for unique elements, you have to go for taking a set. As simple as that. So if you look at this input, what I do is, I'm not clear what this we are doing here to optimize. We are not optimizing anything. This is optimization over recursion in terms of exhausting all possible states. Okay. We're using recursion to exhaust all possibilities which can exist. That's what we're doing here. It is technically just a recursion, nothing else. Okay. Combination themselves must sorted. We are not handling in the backtracking, right? We are. This will take care of the sorting as well. Okay. Let's talk about it. The duplicate values are not allowed because we contain all the unique values. So that condition is already given in the question. What we do is first we start to take the size of the array, then we have the input values, and then we have the sum. What we are doing in combination sum. First thing, this is going to be my final answer, which is going to be a list of lists or 2D array. Everybody clear with line number 2? Come on, guys, quick in the chat. Line number 2, everybody clear? That's going to be 2D array. Now, the input which is given is 7265. What I'm going to do is I'm going to convert it into a sorted array so I can do the backtracking on it. So that will give my list of all possible combinations which are in sorted fashion. So this 7265 will become 2567 and I convert it into a set. Print combinations. Here I'll be printing all the combination that we get by using the backtracking, and I'll be printing the size, whatever size we have got, total 7 permutations we have got, and I'll be returning the final answer. Now, in backtracking function, we take the array, we take the target, we take the combination that we have got so far and the final answer. Now, the base condition which I talk about, if target becomes negative, you don't have to do anything, you return from there. If target becomes zero, this is important. If my target becomes zero, that is when I'm appending in my final answer. And also I'm printing that combination. So if you look at this is one of the answer, this is one of the answers, so on and so forth. If the target is not equal to zero, target is not negative, means target is positive. If target is positive, what do you need to do? You need to backtrack. If you backtrack, your target will become target minus nums of I, combination will become combination plus nums of I. That's it. So if you do it in that format, you got these 7 combination where the size of the combination is equal to 7, and this is what we are printing on the screen. Everybody crystal clear with this? Come on guys, quick in the chat. The problem was not complicated. The problem is hard, no doubt about it. But you need to decipher the 5 conditions as we did one by one. And then once those 5 conditions are crystal clear to you, then you can move on to the second part, which is understanding how to solve those 5 conditions. Majorly 2 parts. First, convert them into a set to take all the unique values and get the values in a sorted fashion so that you can have the ascending output always. Let me take this code to Sublime Text first, so everybody's clear. And just make sure you understand this. It's easier to code in Python. That's why I've written the code in Python. I'll show you the Java version on LeetCode as well. Okay. This has good variation, combination some 2, 3, and 4, I guess. 4, I'm not sure. 2 and 3 are there for sure. Okay. That also you can test. Let me take you to the LeetCode version. Okay. There is the LeetCode version for combination sum. Same piece of code. I've just added a template which will work for all the combination sum 1, 2, 3 template. Okay. If you look at this piece of code, this is doing the same thing. I'll take this part to make it easier. Go back to Sublime. There you go. Once the code is clear here, then we can go ahead for submitting. See, straightforward code. This is backtracking. What you're doing here is you create a list of lists, which is a 2D array as your answer. You sort the array candidates initially. Why do you sort it? So you can get the sorted list of permutations. Now you're calling backtrack function. In backtrack function, what do you have? You have the list of integer answer. You have one answer which you have got, which you call as temp list. You have got original array. You got the target. You got the index. Now, condition here, if target becomes negative, nothing to add here. If target becomes 0, add here. Anything, any doubt until so far? Exactly same code that you have written in Python, we are just converting it into Java. Nothing is changing literally. Okay. Line by line, it is exact code if you compare at it. We got this, we got backtrack, then we return it. Line by line, it is exactly same code. Okay. Now the last part is when you apply backtracking, what do? You travel over all the array values. You do temp list.add in that particular temporary list or combination that you have got. You added that value. You backtrack for that value, and then you remove from temp list.size minus one. It's one of the way. If you don't want to do it, you can just simply move by I plus one. Okay. Alrighty, guys. Since we are doing both include and exclude, time constant will be 2 raised to the power n, space quantity will be big of n. So this piece of code, I will take it here. Time constant big of 2 raised to the power n, space quantity big of n. Okay. And the LeetCode version, I'll keep the code. Okay. Let's go ahead and submit on LeetCode to verify our logic is correct or not. Let's compile this. Will it work? Yes, let's submit it. pass all the test cases. Okay. All right, guys. Let me go back to Sublime now. Anybody, any doubt in this question? If it is clear, just type clear. Cool. All right, let's quickly revise what you've done as part of today's session before wrapping up. We got 2 questions done for backtracking. We do have 8 more questions that we have to cover as part of variation of retinal layers, which we'll do tomorrow. So tomorrow, most likely our backtracking will be completed. Then we'll move on to trees and graphs. Now, quick check. Where did we start? Backtracking is optimization recursion without storing the state results. The understanding is we are going to exhaust all the possible states here. Okay. So there are 2 simple steps to it. It's not like as elongated as a DP with 4 steps. One is to identify, second is to apply backtracking. How do you identify? You look at the problem statement, you check the keywords. The keywords gives you indication whether it can be solved or not solved. Okay. Wherever you get the intuition that I have to exhaust all possible states, that is when you know it's a backtracking based question. Second is the example we talked about for n queens and retinal lines. Second is to apply backtracking, you have to work with choices, either include or exclude in a combination. If you include it, what is going to happen is your current sum will become current sum plus new number, target will become target minus current sum. If you exclude it, current sum will not change, target will not change. We start with the first question, which is subset sum problem, a very good question to talk about. How did we solve that question? Simple 4-5 lines of code. First, we applied the template to understand how to do it. We write the base conditions here and the 2 possibilities for include and exclude. So these are the base condition here. 2 possibilities, one for include, one for exclude, and the most important part, return include or exclude. Why? Because you might get a combination with combination of including or excluding some element. Time constant to raise the power n, space prompt big of n, as we discussed. Then we talked about combination sum on Facebook. This was the online assessment asked. This has been also asked in the lead code version. So if you go to the online assessment, this is the question. First, we decipher the question with every possible condition which is given to crystal clear understand the question. And once we understood the question, then we talked about the approach. What exactly is the approach? The approach is we are going to sort the array initially before applying backtracking to get the sorted permutation, because backtracking in sorted array will give me a sorted permutations. Second, for the unique values, I can use a set here. Then we talked about the base condition, actually implementing the backtracking. We have written the code for the online assessment one, finally written the code for the lead code variation one. Time constant to the power n, space comp to big of n, and it passed all the test cases. All right, guys. That being said, everybody crystal clear with today's session. Any doubts, any questions, let me know. For the DP notes on lead code, I will just take a PDF version of it and I'll share it in your group. Okay. Thanks for reminding. All right, guys, if everything is clear, let's wrap up the session here for today. Let's catch up in the next session where we'll be completing backtracking tomorrow. And then the next subsequent section, we'll be going for trees and graphs. Okay. You should have received the assignment for our dynamic programming by now. If you have not received it, I will ask your course coordinator to give it to you. Okay. All right, guys. Thanks for joining in. Have a good one. We'll catch up in tomorrow's session.